This is AP Calculus AB, section 2.2, infinite limits, page 2. Previous page we worked on finding the limit via a graph. Now we're going to take a look at analytically finding these limits without a graph, so no calculator. All right, let's look at this one. The limit as x approaches 1 from the left of x plus 2 over 1 minus x. First thing that we do when we evaluate limits is substitute in. So let's go ahead and do that. When we substitute in a 1, we'll get a 3 over 0. When this situation occurs, when we have a non-zero constant, in the numerator and a 0 in the denominator, this tells us that the limit is positive or negative infinity. And you need to do something called a sign analysis to figure out whether it's positive infinity or negative infinity. So what we do is we take, this is 1 from the left, that's a tiny bit smaller than 1. Something smaller than 1 like 0.99999. And all you're interested in is the sign, not the actual numerical value, just the sign. So 0.99999 plus 2 is positive. Down here, 1 minus 0.9999999, that's positive. Positive divided by positive is positive, so the limit is positive infinity. Let's look at this one. The limit as x approaches 1 from the right. Again, substitute in. We're still going to get 3 over 0. There's that non-zero constant over 0, and we have to do a sign analysis. One from the right is something a tiny bit bigger than 1, like 1.00001. And again, all you're interested in is the sign, not the numerical value. So 1.0001 plus 2, is that positive or is that negative? That's positive. 1 minus 1.00001, that's negative. Positive divided by negative is negative infinity. So this limit as x approaches 1 from the right of x plus 2 over 1 minus x is negative infinity. Let's look at this problem here. 4 f of x is equal to x minus 4 over x squared minus 16. I want you to find the limit as x approaches 4 from the left of this function. This limit, that one, I'm not going to read them all to you. Then, when we're all done, I want you to use this information to sketch a graph. Sketch is no calculator. Sketch is no calculator. All right. Right off the bat, when you look at this function, you should see that that x squared minus 16 factors. So our function, x minus 4 over x plus 4 times an x minus 4. The x minus 4's divide out, and we are left with 1 over x plus 4. So there's that simplified form. Let's list all these limits down here on the side that we need to find. The limit as x approaches negative 4 from the left. The limit as x approaches negative 4 from the right. The limit as x approaches 4 from the left. The limit as x approaches 4 from the right. All right, 4 from the left. When we substitute in and go into this simplified form, when we substitute in a negative 4, we end up with 1 over 0. There's that non-zero constant over 0, so we need to do a sign analysis to figure out if this is positive or negative infinity. When we plug in negative 4 from the left, that's a little bit more negative than negative 4, like negative 4.01. Up here, numerator is positive. Denominator, negative 4.01 plus a 4, that's negative. This is going toward negative infinity. Negative 4 from the right, same idea. When you substitute in, we get a 1 over 0, so we need to do a sign analysis. Sub in negative 4 from the right. It's a little bit less negative than negative 4, so negative 3.99. And again, numerical value is not what you're interested in. You are interested in sign. Negative 4, let's see. Numerator is always positive because that's 1. Negative 3.99 plus a 4, that's positive. So that's positive infinity. These two answers right here tell you there is a vertical asymptote at x equals negative 4. Looking at these two limits, now we substitute in x equals 4 from the left, so we just put a 4 in here, and that's 1/8. 4 from the right, again, 1/8. All right, these two pieces of information tells you there is a hole at 4, 1/8, because the limit as x approaches 4 of this function exists, but f of 4 does not exist. Go back up to the beginning, way in the beginning of here, over here, x equals 4. You cannot substitute in an x equals 4 because you get a 0 in the denominator. So the function does not exist there, but the limit does. There's a hole. And you'll see that a little bit better when we sketch the graph. A few other things that are going to help you sketch this graph is to find the x-intercepts and to find the y-intercept. X-intercepts happen when y is equal to 0. We can set that simplified form. So we are looking for 1 over x plus 4 to equal 0. That cannot happen. The only way a fraction can equal 0 is if the numerator is equal to 0. This can't happen. There are no x-intercepts. This graph will not cross the x-axis. Y-intercept happens when x is 0, and if you plug in x is 0, we'll get 1/4. That tells us that we have a y-intercept at 0, 1/4. That's an important piece of information. All right, let's sketch this graph. I'm looking for a ruler and I don't have one close by, so we'll have to freehand it. Okay, here we go. We know we have a vertical asymptote at x equals -4. Put that vertical asymptote in. there is a hole at 4,1/8. 4,1/8, right there. X-intercept, this graph never ever ever crosses the x-axis. It has a y-intercept at 0, 1/4. So right here. And now we can start using some of these limits. Coming at -4 from the right-hand side. So from this side, the right-hand side, those y values are going up toward positive infinity. So as I come toward -4 from the right, these y values have to increase. And we have to hit this point, and we have to hit that hole. So we can start to sketch this in. And this has to come up like this. And this is going to come down and flatten out. There is a horizontal asymptote here. This hole is at 4,1/8. On the left-hand side of -4, left-hand side, as x approaches -4 from the left, the y values decrease without bound. So they're going toward -4 from the left. Those y values have to decrease. So they're going like this. And I'm going to draw over my writing. Sorry about that. And this has to flatten out because this graph will never, ever, ever cross the x-axis. And that is the end of page 2.